In this chapter, we will be looking at quadratic equations. In this lesson, we're going to look at how to solve simple quadratic equations using factoring.
Alright, hi everybody. So in this lesson we're going to take a look at solving quadratic equations. We're going to look at them solving by factoring, very specifically here. And actually as we go through our examples here, they're not all going to be quadratic. Some of them are just going to be like little linear equations that we're going to solve. Basically just to kind of illustrate how this happens. Now there's a little procedure that's mentioned here. So when you got a quadratic, you always want to move everything over to one side of the equation. Okay, so it is equal to 0. Okay, and that's actually really important. Okay, I've seen all sorts of students who try to jump right into solving without setting it equal to 0. But when you do that, you've actually, I mean, unless you are really comfortable with algebra, then I mean really comfortable, you're missing kind of the primary idea here behind solving, and I'll explain that in just a second here. But then what you do is you look for greatest common factors, and then you solve, so you factor normally, and then you're going to set each factor equal to 0 and solve for x. So what we're doing is we're taking, with a quadratic, we're breaking it up into little linear factors, and then we're going to set each one of those equal to 0 and solve. Now the reason why that works is, let's say that you know that a times b is equal to, let's say, 2. Well, what do you know about a and b? And I suspect out there some of you are thinking, well, one of them, a is 2, b is 1. Well, okay, or a is 1, b is 2. And that's true, that could work, but that doesn't have to be the way that works. It could be a is 4, b is a half. It could be a is a half, b is 4. It could be a is a third and b is 6. There's a ridiculous number of options. There's an infinite number of options as to what this could be here. However, compare that to this. If you know that a times b is equal to 0, well, now this is a little different. Hold on a second. I know for a fact one of those two is 0. So over here, when I multiply a times b, I really have no idea of a value for either one of those. Once I know one of them, I can figure out the other. But here, when the product is equal to 0, now I know one of the values that has to show up here as one of the factors here. Now I don't know which one it is. Okay, I don't know which one it is. It could be that a is equal to 0, or it could be that b is equal to 0, and then it turns out in both cases those are possible solutions to this equation. So I have two solutions to this. And so that's why I bring everything over, set it equal to 0, because all of a sudden that collapses all of the potential possible answers and really focuses my attention on just two possibilities. And then I solve each one of the little equations that I create. Now, let's take a look at some examples so you can see this happen. And what we're going to do here is we're going to start with some linear ones and then work our way up. Okay, so here we go. We're going to solve each of the following equations here. Now notice this is just a linear, okay, a linear equation. There's no squares here, so it's not quadratic, it's just linear. But I'm going to do the same thing that the outline there suggested. I want everything over to one side, set equal to 0, good. I'm going to take out any common factors, and I do have a common factor of 3 here. And then I get x minus 4 equal to 0. So these two factors multiplied together giving a product of 0. So 3 times x minus 4 is 0. Now bear in mind there are two factors here. It's the 3 and the x minus 4. That binomial is a single factor. I know for some people that takes a little bit of getting used to, but that's how that works there. Well, the 3 is not the thing that's responsible for making this equal to 0. It's going to be this x minus 4 that's going to cause that to equal to 0. And so now I know that this has to be equal to 0. It's the only way this product will equal 0. And if that's true, then in order for me to solve this, I'm going to have to bring that 4 over to the other side. I have to isolate it by adding the 4. And so if I add 4 to both sides, I get that x is equal to 4. And there's my solution to this equation. Okay, now over here, for this one right here, notice that what's going on in this case here, we're kind of meeting it partway through this problem. Really, when I want to solve, I want to isolate the x here. Now, this is not equal to 0. Okay, and normally we would do that. We would set it equal to 0. But in this particular case here, really what's happened is it's like I'm looking at this equation and I've already brought the term over and I'm about to solve by dividing. So what I really want to do here is just divide both sides of this equation by 16. So x is going to be 20 over 16. Now that's a terrible way to leave that because there's a common factor of 4 to both of those. So I really should say that x is equal to 5/4. Okay, if I divide out the common factor of 4 to 20 and 16. So this is partway through that process. So this is why in this particular case I wouldn't set it equal to 0. I wouldn't bring the 20 over. But if this was a quadratic, then I couldn't get away with doing that because it's not as straightforward. Okay, now here is going to be a question that's a quadratic because I've got x multiplied by x. It's just not expanded. It's in factored form. That's actually a benefit to me because I've got this factor multiplied by this factor is equal to 0. Now, one of these two factors is causing the result to go to 0. Is it the x plus 7 going to 0? If that's the case, then that only goes to 0 if x is equal to -7, because -7 plus 7 would get you 0. Now, this factor here, if you plug -7 into it, this factor doesn't go to 0. It's going to go to -11. That's okay, because this is the thing that's going to cause the product to be 0. It would be 0 times -11, boom. So there's one possible answer. Or it's the x minus 4 that's causing this product to go to 0, in which case that is going to 0 when x is equal to +4. And it's the same thing over here. This is not going to 0. This is going to become 11. But that doesn't matter because this factor over here is becoming the 0 when x is equal to 4, and it's causing the whole product to go to 0. So of all the infinite number of possible values that x could be, these are the two values that both cause this product to go to 0. So those are my solutions. Now, same thing with this question. This question's already been factored. If you multiply that x through, you will get a quadratic. What's nice about this question right here is it gives us a quick opportunity to look at what happens when an x is all by itself. A lot of times people get so used to this idea of we're setting it equal to 0, we're looking for the value of x that creates this 0, that sometimes the assumption is, and it kind of sneaks its way in really subtly, the assumption is that x is 0. And so I'll even have people that look at this and say, oh, one of the solutions is x is 0. And that's not true. If x is equal to 0, this becomes 7, this becomes -4. Okay, if you cancel out those x's there, and 7 times -4 is -28. That's not 0. So plugging in 0 for x doesn't work necessarily all the time. But here it will, because x is all by itself one of those factors. If I take a look at each factor separately and set it equal to 0, well, here I get x equal to 0 all on its own. Now here, I'm going to have to bring over that 13, and then I've still got a coefficient here, so I've got to divide by that too, and so I get x is equal to 13/2, or x is equal to 0. And those are my two possible solutions that make this equation equal to 0. Okay, so I hope that makes sense. This is the sort of scenario that we're looking for, that's going to spit out as 0 as the solution for as one of the solutions for x here. Okay, now here, this is sort of what the little outline up above here was talking about. First thing I want to do here is set this equal to 0 by bringing that 6 over. And remember, when a term moves from one side of the equation or one side of the equal sign to the other, it has to switch signs. Now I'm going to factor this. And I'm going to do this by guess and check because that's going to be a pretty quick method for a lot of these. I'm looking for factors of -6 that add to a -1. Now because the product here is negative, I know one of them's negative, one of them's positive. And because this is negative, I know that the larger number here is going to be the negative one. So when I tear apart the 6 here, that's going to be 3 and 2. And yeah, and that's what's going to create for me that -1 in the middle. So now that I've got it factored, I know that in order for that product to be equal to 0, either the x minus 3 is 0 or the x plus 2 is equal to 0. Now let's take this one step further. What value of x would cause x minus 3 to be equal to 0? Well, bring the 3 over. Positive 3 would cause this to equal 0, which means the whole thing equals 0. And I do the same thing over here. If I bring that 2 over, I'm going to get negative 2. So either one of these would be a possible solution for this quadratic. So we're seeing that we can get two solutions here with a quadratic. Okay, x squared minus 5x. So I bring everything over to one side. That already is. Okay, so that part's done. Now I'm going to factor this. But this is just a binomial here. There's only two terms. So this doesn't require that kind of more complicated trinomial factoring. In fact, all I'm going to do here is take out the common x. Well, now I've got that in factored form here. And this is similar to the one that was just above it here with this x. And this is basically why it's here, so that you can see what the function looks like that creates that scenario here. There's just this common factor of x. So either that x all on its lonesome is going to 0, or that factor of x minus 5 is going to 0. And this is already solved, and so this one right here, I'm going to bring the 5 over. So x could be equal to 5. So either one of those is going to cause this equation here to be satisfied. Would make it 0 equals 0 on both sides there. Okay, let's keep going. Let's do a few more here. So now for this one, we're going to bring everything over to the same side of the equation, just like we were doing before here. So I'm going to make this 2x squared minus 9x minus 5 is equal to 0. And then I'm going to factor this using decomposition. So I'm going to be looking for two numbers whose product, and now remember, when I multiply the first term by that last term, it's going to be negative 10x squared. And my sum is going to be negative 9x. Remember, this is my first and my last, and this is my outer and my inner. And I'm looking for two numbers whose product is negative 10x squared and whose sum is negative 9x. So I think that's pretty clear. It's going to be negative 10x and positive 1x. Okay? And so now what I can do is I'm going to go over here. I'm going to rewrite that negative 9x. So I'm going to make this 2x squared minus 10x minus x minus 5 equals 0. And now I can use decomposition. I can use grouping, okay, which is the second half of decomposition here. So, and remember, I'm going to split this up. So my first two terms are grouped together, my last two terms are grouped together, but that negative sign is always going to get shoved over, okay, and I'm going to put a big positive sign in between. And now, what's common to 2x squared and negative 10x? Well, it's going to be positive 2x. Whoops, forgot the x. X minus 5 when I, x minus 5 when I pull that out. Oh, I'm sorry, this should have been a plus x. I'm sorry, going back here, wow, what a mistake. I'm sure a whole bunch of you caught that before I did. Sorry, that was a positive x right there. That should have been a positive x, positive x. As I was looking at that in my head, I was thinking about the negative, and then I just threw it down there. So here, I've still got that x minus 5, so I don't really have to pull anything out. There really is nothing common, and the two binomial factors are common there, that x minus 5. So now that x minus 5 is distributed to a 2x, and if there's nothing written out front there, we know that that implies a 1. Okay, so now I've got these two binomial factors multiplied together, and their product is 0, which means either the first factor is giving me the 0, or the second factor here is giving me the 0. Both of those will do the same thing here. I'll bring the the negative 5 over, which means it becomes a positive 5. And now, when you've got a coefficient in front of the x, that just means I've got an extra step here. I'll bring the 1 over, so it becomes negative 1. And then I've got to divide by the 2 here, and I get negative 1/2. And so my solutions here to this equation will be 5 and negative 1/2. Both of those work. Now let's take a look at this one. Okay. Now this one's a little bit different here, and don't make classic mistake that people make here is immediately like set this equal to 0, and they'll tell me, oh, the answers must be negative 2 and negative 3. Except that this doesn't equal 0, it equals 12. So I need to bring the 12 over, but there's no point in bringing it over if it's written like this. So what I need to do here, first of all, is I need to expand this out. Get x squared plus 3x plus 2x plus 6 equals 12. And then I'm going to bring the 12 over and I'm going to group together like terms. So x squared plus, well, I've got 5x on that side, and then I've got a positive 6 minus 12 give me negative 6. Now I'm going to factor this just using guess and check because I think it'll be a fairly simple one to factor here. Especially because x squared can only be broken down into x and x. And then this is negative 6, okay? So I know that the two factors here are going to be positive and negative, and because this is positive here, I know that the larger the two numbers is going to be the positive. Now, I could do 2 and 3, but because they're going to have opposite signs, whether I add them or subtract them, there's no way I'm going to get 5 out of that. So actually I had to think about this a little bit differently. I got to think that that's probably going to be 6 and 1, with the larger number here being the positive and the smaller one being the negative. And so now I've got these two factors multiplied together giving me 0. So either the x plus 6 factor is equal to 0, or the x minus 1 factor is equal to 0. In which case I'll bring that 6 over and I'll get x is equal to negative 6. And here I'll bring the 1 over and I'll get x is equal to positive 1. And so there are my two solutions, negative 6 and positive 1. Okay, now let's take a look at this one. 3x squared equals 6x. Okay, now again, the first thing I want to do is make sure that this is equal to 0. So I'm going to bring the 6x term over. I like to have the quadratic term positive here. It just makes my factoring a little bit easier if I don't have to worry about a positive or a negative here. I've only got two terms, so I might be tempted to think that this is a difference of squares, but the first thing I should always look for here is common factors. And I've got a 3x there, so I can factor a 3x out. And that's going to leave me with x minus 2. And so now I've got these two factors, well actually I've got three factors here really multiplied together. I've got the 3, the x, and the x minus 2. But the 3 is not what's causing this to go to 0. So the 3 isn't even an issue here. But that x could be. It could be that that factor of x all on its own, when x equals 0, causes the whole thing to go to 0. Or x minus 2 is equal to 0. And if x minus 2 is equal to 0, I know by bringing the negative 2 over that x could be positive 2. And so my two possible solutions here would be 0 and positive 2. Over here, now this isn't a quadratic, and that's okay. Notice I've still got a common factor of 5 though. It is equal to 0. It doesn't have to be equal to 0. What I could do here, and actually I'll do two different things here. What you could do is factor out the 5 and make that 5 times m plus 3 is equal to 0. And then because that's true, I would set m plus 3 equal to 0, which means m would equal negative 3. Or another way I could do this is bring the 15 over right away. And I can do that because this is a linear factor. Okay, this isn't a quadratic. I'm only going to have the variable m show up in this once. And actually, even if there were a whole bunch of m's in there and they were still all degree 1, the first thing I would do would combine them all together first anyway. So I could still do this regardless if it's linear. And then divide by 5, and I will get that m is equal to negative 3. So either way, I'm going to get m is equal to negative 3 as a result. Okay, and finally, I've got this 4x squared equals 64. And again, there are two ways of handling this. But to be consistent with what we've done before, I'm going to bring the 64 over, because this is quadratic. So I've got 4x squared minus 64 is equal to 0. And I'm going to factor that. And I see that they've got two terms here. But the first thing I'm going to do before I check for difference of squares is I'm going to divide out that 4. So I'll pull that out, and then this will give me x squared minus 16 is equal to 0. And now I'm going to look at what I'm left with here. And this is, in fact, a difference of squares. So I know that I can factor this as two binomials, okay, square root, and then it's going to be minus the square root of 16 plus the square root of 16. And when I tear this apart like this, I've got these three factors here. Well, I know 4 is not the reason this is all going to 0. It could be the x minus 4 becoming 0, or it could be the x plus 4 becoming 0 that creates this product of 0 at the end here. If it's x minus 4, then I can bring the 4 over, and I get x could be positive 4. If it's the x plus 4 that's going to 0, then that means, bring the 4 over, I'm going to get x equals negative 4. And those are my two possible solutions here. Or, Another way that I could have handled that would have been to just treat it, work with it like this. So I'm just going to move this over a little bit. I could have started with this. And this is a slightly quicker way of doing this, but it's conceptually a little bit more difficult for people. The first thing you want to do here is divide by 4. So I'm going to get x squared is equal to 16 because I got to get the x by itself. And now what I'm going to do is I'm going to take the square root of both sides, which isn't a problem, okay? Because the square root of x squared is x, the square root of 16 is going to be 4. Except the problem is if you leave it like this is incorrect. And the reason for that is basically what this is saying here is I squared a value and got 16. Okay, so what was that value? Well, typically what you do is you just take the square root of 16. Well, the square root of 16 is positive 4, but there's a little bit more going on here because I'm not just asking what's the square root of 16. What I'm saying is something got squared and it produced 16. What was that something? Well, that something could have been positive 4 or it could have been negative 4. So I have to address the plus or minus that pops out when I answer a problem like this. Okay, now let's just compare that really quickly here. If I had told you that x is equal to the square root of 16, this is a slightly different problem here. Okay, now it's related, it's very closely related, but this is a different problem here. And if I was to ask you what's the square root of 16, the answer is just 4. Okay, but in this particular case here, I'm not. And I know it's just a very, very subtle difference, but it is a difference here. I'm not asking, like I am here, I'm not saying something squared gives me 16. I'm just saying x is equal to the square root of 16. What is that? Well, the answer is 4. Okay. This is a very closely related problem, but it is different. And any time that you're going to drop the square off of a variable, you need to include the positive or the negative options there. This is something that I have addressed in another video here, and perhaps if it becomes a bigger issue in this chapter, I'll address why this is the case then as well.